All right, well, welcome everyone. I am JJ. Let's tackle an example problem. So we're saying, let's use our method of joints to determine the force in each member of our truss that we have here. So let's go ahead and go for it. So our first step, before doing this, I need to figure out my support reactions. I know I have a 6 kip force here and a 12 kip force there. Let's just come in and draw in our free body diagram. Let's actually stick it here. So I have AB going straight down, BD going horizontal, and A to C to D going diagonal with a member right here as well. At A, I have a roller, so I know from a roller I should have one force perpendicular to whatever surface it is rolling up against. If that surface is vertical for the roller, then my support reaction perpendicular to that will be entirely in the x direction. So let's call this AX. If I go 3 feet up from that, I'm going to get to point C. So let's go ahead and label that 3 feet. And 3 more feet from there is going to get me to the very top of my truss where I have my pin. 3 feet again. Gets me to the pin. That pin at B will always, for a pin, put in an X component and a Y component. So I'm going to guess BY goes up and that BX goes to the left. I know as I go to the right from A, if I go over 4 feet, I'm going to get to a 6 kip force. 4 feet and 6 kips. And 4 more feet gets me to the far right edge where I have a 12 kip force. So I'll stick that along the top as well. 12 kips, just coming straight down. 12 kips. That should be my free body diagram. I can come in here and apply rigid body equilibrium to the entire truss to figure out what are my support reactions for this. So let's come in and try to do that. If I come in here, I have 2 unknowns in the x direction. I probably don't want to start there. I have only 1 unknown in the y direction. I could sum forces in the y first, or I could do moments. Either at A, we'll get rid of AX and BY, I'd find BX, or I could sum moments at B, get rid of BX and BY from that, and I'd find AX. Really, there's 3 places I could start at. Let's do moments at A. So I'm going to say with positive, going anti-clockwise or counterclockwise, summing my moments at A. I'm going to get BX is causing a positive rotation, counterclockwise, and it's 6 feet away. So 6 BX. My 6 kip force will cause a clockwise rotation, so minus my force is 6, and my distance is 4. And then my 12 kips will also cause a clockwise rotation, minus force 12 times distance, 4 plus 4 is 8. And that should get me to 0 equals 0, which if I solve that for BX, I'm going to get that BX is 20 kips, and it's going to the left. So if I make a free body diagram of joint B, I'll need to include 20 kips to the left at it for BX in there. With that known, why don't I sum forces in the x direction? Summing forces in the x. I have AX to the right minus BX, which I just found is 20, so minus 20 should get me to 0. Or solving that for AX, I'm going to get that AX is positive, which means I have the correct direction here, 20 kips. To the right for this one. And then finally, I can sum forces in the y. I could have started with this one as well, but we'll get in here as the last one. Summing forces in the y direction. I have BY as an unknown going up. BY. I have 6 kips coming down. And I have 12 kips coming down. Minus 6, minus 12, gets me to 0. Or solving for BY, I'll get my third support reaction. BY is 18 kips. 18 kips going up. Which means I have all 3 of my supports calculated out. I can take that and then move forward and start trying to say kind of the newer material method of joints will be to look at individual pins in here at A, at B, at C, or at D. I want to go somewhere where I have at least one unknown force and at least one known force. I can only do 2 equilibrium equations. I'm basically going to do particle equilibrium over and over. So I can sum forces in the x and the y. That means as I tackle this, I need to have no more than 2 unknowns for everything. So for example, I don't want to start at C. I would have BC as an unknown, AC as an unknown, and CD. 3 unknowns in there. I have 2 equations. We can't find 3 unknowns with 2 equations. It's mathematically impossible. So that's a terrible place for us to start. Same idea at B. Even though I know BX and BY, I would still have AB, BC, BD, 3 unknowns there. At A, I know the roller. I'd have an unknown AB and an unknown AC. I could start right there. I could also start up here at D. I would have BD unknown and CD unknown, and a known 12 kip force in here. I'm going to come in and start at point D on this. So we'll come up above, and I'm going to start making free body diagrams up here. So we'll draw in a circle for our pin. That's pin D. I know I have 12 kips on this, going straight down. 12 kips. I also know any member that connects in at this point needs to show up as an unknown. And we always assume tension on these. So tension leaves the pin. I have member BD. So I'll show it. It goes entirely to the right. So just an unknown force in tension going to the right. That was member BD. So let's call that FBD, the force in member BD. I also have going down into the left here in tension, member CD. So I'll include that one in here as well. FCD for the force in member CD. And my angle for this, I could come in and figure out how far over does this go, how far down does it go, or I could catch member CD goes down 3 feet and over 4 feet. This is a 3, 4, 5 triangle. Let's just label it that way. 4 is that horizontal, 3 is the vertical for everything in there. And then the implied leg is 5, which we could label or leave off. But that's enough for us. I have 2 unknowns. Let's come and find those. Right now, there's 2 unknowns in the x direction. Both of my unknowns are in the x. Only FCD is unknown in the y. So I'm going to start by summing forces in the y for this. Summing forces in the y. I have 12 kips coming down, so negative 12. And I have FCD coming down, so minus, I want just the y component of this. So the y leg of the triangle, 3, divided by the hypotenuse, 5, times my force, FCD, is going to get us to 0. Which if I solve that for FCD, I'll get that my force in member CD is 20 kips. 20, or actually it comes out to be negative 20 kips. So what does that negative tell us in here? That means it's negative 20 kips in tension, how I originally assumed this. We don't want to present our answers with a negative though. We want to get the correct tension or compression statement and then say where we'll always show it as a positive. So I get a negative here. I'm going to come in and put a dashed arrow in here. That helps me remember any future equation that I set up. I need to use that in compression. It's really in compression. I assume tension. The dashed arrow lets me know what it's really doing in here. And then I'll report my answer as a positive. FCD is a positive 20 kips. And we're not in tension. I drop that negative, so I'll change that T to a C. Compression. Always for trusses, give a positive answer and then say T or C for it. That'd be one of my answers. From here I can come in and use my other equilibrium equation. Let's sum up my forces in the x direction. If I do that, I have, FCD, I now know goes up and to the right, even though it's in compression, it's in the positive x direction. So I'll put that in there as a positive. We want just the x component. So the x leg of our triangle, 4 divided by the hypotenuse, 5 times FCD, 20, is the x component here. FBD goes to the left, so minus FBD equals 0. Which if I solve that for FBD, I get a positive number out from this one. FBD is a positive 16 kips. And because I get a positive number out, it means our tension assumption was correct. We can say T for tension on everything in here. But that would be my second answer. And that's everything I can really find with this free body diagram in here. F kips in tension. So we can come in and say, well, then we should just move on to a new joint. with BD and CD known, now if I went to joint B, I would just have AB and BD as unknowns, and BC is an unknown, BD is now unknown, and we still know our pin supports. At C, I now know CD, so my two unknowns would be BC and AC. I could go there. And we said originally I could start at A. Really, I could go to any pin that I want to in here. I'm going to go in and tackle pin B for my next one. So come down below and just draw it in. So going to point B for everything. I know that I have member BC or BD in here. I found BD already. It was in tension, which means it's still in tension here. Should be acting away from our pin. So going to the right now, in tension, pulling apart the pin. I have FBD equals 16 kips. I also have B. At B have our pin. So I need to put in my X component and my Y component in here. I know BY I found was 18 kips going up. So I'll put that in, going straight up. BY equals 18 kips. And I know BX shows up here, 20 kips to the left. So going straight over to the left, BX equals 20 kips. And then I have my two unknown members, AB and BC. AB goes straight up and down. So if I'm assuming tension, which we should be doing, put it straight down. FAB, the force in member AB is unknown for us. I shouldn't say that's equal to anything yet. But my last thing that I want to get in here is I also have member BC. I'm again going to assume tension, so it goes down and to the left. FBC, the force in member BC. And that also goes down 3 over 4. This is also a 3, 4, 5 triangle. 3, 4, we'll let that 5 be implied. Two unknowns in here, FAB, FBC. I should be able to come in and find both of them. So let's come and apply equilibrium. So which equation do I want to do first? Some forces in the X, some forces in the Y. Again, look at how many unknowns we have in each. I have two unknowns in the Y direction, only one unknown in the X direction. If we had two unknowns in both directions, we could still find this. We just have to make a system of equations. But if we can do one equation and find one unknown, that's the better starting point. So let's start with summing our forces in the X direction. If I sum my forces in the X, I'm going to get that I have the X component of FBC, 4/5 of FBC. I need to add in FBD plus 16, and I'll need to subtract out BX minus 20. Is going to get us all the way to 0. Which if I solve that one for FBC, it's my only unknown in there, I should get the FBC. I get a positive number out here, so I do have the correct direction assumed. It should be 5 kips, 5 kips, and it's in tension. And I know it's in tension because I get a positive number from this. So my free body diagram is showing the correct direction on that. And then I can come in some forces in the Y direction. With FBC known, I now have one equation with only one unknown in it. Summing forces in the Y will get me FBC. So let's tackle that one. Summing forces in the Y direction. I have BY going up, 18, minus the Y component of FBC, or minus 3/5 times FBC, 5, minus FAB. Minus FAB should get us to 0. FAB is my only unknown here. If I solve for it, I get a positive number. So again, this one is in tension, and I'll get that it is 15 kips. FAB equals 15 kips, and we're in tension, which is our next answer. I have just one unknown that I still need to find. I haven't found FAC yet. And there's two ways I could come in and do this. I could go to pin C. I would have FAC show up in there. Everything else is known. Or I could go to pin A, where the roller is at. Again, only FAC would be my unknown. I'm going to tackle this using pin A. So come in and draw it in. At point A, I need to have my AX. I found it was 20 kips to the right before, so we'll still be doing that here. AX is 20 kips. AX equals 20 kips. I also have here, remember AB going straight up and down. I found FAB was 15 kips in tension a minute ago. That's still going to be true now. So it still is in tension, acting away from our pin. FAB equals 15 kips. And then my last unknown, I have FAC. I'm going up and to the right, so I'm going to move where I wrote FAB, so I have room for FAC to get labeled. FAB equals 15 kips. And then going up and to the right, I have FAC. The force in member AC will be my final unknown I need to find in here. FAC. And it's also at a 3 vertical, 4 horizontal, 5 for our hypotenuse triangle. 3, 4, 5. FAC shows up in both the x and the y directions. It's my only unknown, though. I could realistically use either equilibrium equation to get this one figured out. We'll get the same answer either way. Let's come in and I'm going to sum forces in the x. Summing my forces in the x, I have AX 20 plus the x component of FAC. So I want the x leg of the triangle, 4 divided by the hypotenuse of the triangle. That implied leg is 5 times my force. FAC should get me to 0. Which if I solve that one for FAC, I'm going to get that this is a negative answer. FAC is negative 25 kips. Negative 25 kips. That's negative when we assume that we are in tension. If I get that negative, I'm going to put in a dashed line just to stay in the habit that this is really in compression. So if I want to check my work later, I know where that's actually coming from. I'm going to report my answer as a positive in compression. FAC. We get rid of the negative, so equals 25 kips. And change our T to a C. Compression. FAC is 25 kips in compression would be our final answer. Always for our trusses, report as a positive and say T or C. But we'll go ahead and wrap up there. Hopefully this is a useful video for you. If it was, hit those like and subscribe buttons. Stick around. Let's get you an A with JJ.